welcome the third presenter, Hui Jinzhu. And the presentation, the title is the development and the application of totally grid-oriented ubiquitous augmented reality learning system.
Search very slowly. But it should be okay because it's all made in Japan, I think.
How come it's not supported?
你那个解析度是不是太高？
没有啊。
一定要切两边，就是勾切一下。
先切着过去的，就是
Yeah, processing. Yes.
Okay. Thank you. So maybe that is Chu come here and then it worked. Okay. Nice to meet you, everyone. I'm Hui Junju from Suzhou University of Taiwan, and today my titles and Professor Yang already read it. So I just go to the next page. And in this study, we implement an augmented reality system and for context-aware learning environment. And we also use regulatory-oriented mind tool. We integrate the two, this technique and this learning strategy. This is learning strategy and this is technique. And we want to find that the new technique can, if the new technique can improve the learning strategy we used before. So that is the reason we implement this study. And we hope that it facilitates the student to observe the learning targets and organize what they have learned in the real world during the learning process. Okay, an experiment has been conducted in an elementary school natural science course, and to extend the students' performance in terms of their learning achievement and learning attitude. Okay, Collins and other researchers have indicated that learning is independent without any linking of the real situation. That means if the students only read the learning materials in the class, inside the classroom, maybe it is hard to have the connection to the real world, to their experience in the real world. So that is the reason we do mobile learning right now, because the popularity of mobile and mobile communication technologies have enables researchers to help or researchers or teachers help the students can learn in the authentic learning environment. So when the researchers or teachers, they implement a learning activity in the authentic learning environment, and the student need to test the two sources of the learning materials. One is from the device, that is the digital learning, the digital materials from the device, and another is they need to test or they need to observe the targets in the real world, right? So they have to focus on the two sources of the learning materials. That may cause them to also have a hard connection because they need to read and they need to observe and they need to read first. And so we want to combine or combine the two sources of the learning material in the same screen and help the student to learn very directly. So this study attempts to develop an augmented reality context-aware learning system by integrating a knowledge construction tool. That is, in this study, we use regulatory methods of the e-learning environment. So there are two variables here, and the first one is learning strategy is different. We use the regulatory oriented mind tool and the tool-based ubiquitous learning. And the other is we conducted the AR technique or don't use. And so after conducting the learning environment, we will analyze the learning achievement and the students' learning attitude. So this is the reference about the augmented reality. AR is an innovative technique that adds virtual objects or supplemental explanations to the things that is the real things. So it can students can read the additional information in the learning objectives in real life. So AR can further support learning by situating students in the real and informative learning context. And the second is they can by linking the supplementary learning content to the real-world target. And this is the Retrograde. Retrograde is the Mind Tools, and Mind Tools is a cognitive tool which helps learners organize their knowledge and engage them in high-level thinking during the learning process. And Jonathan further indicated that the creation of the knowledge basis of expert system is the part of the activity that engages the critical thinking. So Retrograde is the method we usually use to build an expert systems. And this is the matrix of Retrograde. And this columns is a target which students need to observe and classify. And this rows is a construct, which is the characteristics to identify that objects. And this is also 1 to 5 scale rating mechanism. They're usually used to indicate the relationship between an object and an characteristics. If the rating value 1 means that this object maybe they have the characteristics of that shape, and rating value 5 means this is the opposite tendency of the characteristics. So that is the simulated scenario. The student use the tablet PC and then use the camera towards the real objects, and then supplementary materials and explanations will show on the screen and help the students to read the materials and combine with the same thing. And then the system will ask the students to find what characteristic to identify that butterfly. So the system will ask the student, is the butterflies any difference between this butterfly with the other two butterflies of their wing spots? And then that is the tendency, 1 to 5 rating scale mechanism, and this is the this is the construct of the that means the characteristic and the opposite characteristic of the butterfly, and the student can choose what they have found, and they can also use the AR technique and to look at the material again, or they can observe in the real world, and they can choose their answer. And after the student finished all butterflies observation, and the system will show this page to the students that have some alert. And that alert means that the student answer is different, quite different with the teacher. So the student can go back again and watch the butterfly again. So we have 2 variables, so we have 4 groups, and totally that is 86 5th and 6th graders in an elementary school. And the first one is experimental group. The students use the AR-oriented mind tool to learn, and the first, control group 1 use the AR, only AR, no retrograde method. And the second control group use the ORG-oriented mind tools learning system. And the third one use the tool-based U-learning. This is the pure U-learning we already used many times. So here is the procedures. The students will have the 4 classes, and they will be taught the fundamental knowledge of the butterfly. And then they took the pre-test and the pre-questionnaires. And then also we need to teach them how to use the tablet PC. This is a very important part, okay? And they also need to learn what is the retrograde. And then separated for the 4 system. That is the 4 system for the 4 groups. And after the whole learning activity, they took the poster test and the poster questionnaires. So here is the map of the butterfly touch garden. We also showed that in the system. And then there is a photo of the real butterfly touch garden, and the students use the tablet PC to learn. And some butterflies here, so they can observe and they can see. And this is the result. These results show that there is no significant difference between the 4 groups. But we can also see the tendency. Even though there's no significant difference, but the experimental group students shows the higher grades here. And then we can see that the students who use the ARU learning to learn have the lowest adjusted mean. We think that maybe if we only use AR, it can help students to learn in the real world. We still need to use efficient learning strategy. Okay, and then these 2 groups have almost the same. And their attitude, their learning attitude toward the nature science course shows that the student in the experimental groups is better than the third one. That is the pure U-learning, use the tool-based U-learning. And then this control group is a retrograde-oriented mind tools. They use that to learn, show significantly better than the students in AR U-learning and the tool-based U-learning. So we think that AR can improve the retrograde if we use the right strategy. Maybe they have to take the tablet PC to learn, so that something affects their learning performance, but they still feel that it's very interesting. So their learning attitude is still good. So here is the conclusion. In this study, we propose AR U-learning system by integrating a retrograde-oriented mind tool for M-learning and U-learning. And an AR retrograde approach is employed to guide the student to observe and recognize target learning objects in the real world. And it was found that the AR U-learning mind tool is not helpful to students in improving their learning performance and in comparison with the other 3 control groups. And the students in experimental group showed positive learning attitude toward the nature science course than those in the tool-based U-learning groups. but we also found that the students in recovery-oriented UMI tools showed positive learning attitude toward the natural science course than those in AR group and tool-based U-learning group. So it suggested that AR technique it is helpful and it is interesting, and I believe that is a trend, but we need to apply it more effective to improve the learning strategy, the mindful learning strategy. Not just use AR, and we expect the student will benefit from this technique. So maybe that is a different way we need to consider how to improve the learning strategy. Already we know that is efficient in the UMI tools. So this is our findings, and this is this paper. Thank you for your participating, and this. Thank you.
Okay, thank you very much. Any questions or comments? Very great presentation. Very clear. So
Okay.
no question. Oh, yeah, please.
Okay.
But there is Tura-based UI.
Yes.
It means
Sure.
Tura-based UI group. It's a tool.
Which one? Tool-based. Yes.
This group, the user of this group doesn't use.
They use tablet PC. The 4 groups of students use tablet PC.
PC.
Tablet PC.
Temporary.
Tablet PC.
Temporary.
Personal tablet PC.
Yeah. Okay, thank you.
I think it might be a good idea to directly use the recovery method with the AR technology, because when you try to use AR technology, it means that you try to put the real world information and the digital information together.
Yeah.
But when you live in the category, how can you put the category with those information together? I think you need to switch to another page or another place to store the record. I think that's a problem. So maybe in the future we can think about how to format the category
Yes.
to the AR interface.
Yes.
I think you might need to do that.
Yes. Yes. Thank you. And we also considered maybe that is a real problem for the results. Yes. And thank you for this suggestion.
Good suggestion.
Good suggestion.
Yeah.
Yes.
Okay, thank you for the
Okay.
again.
Thank you.
So let's welcome the fourth and also the final presentation of this section. Professor Ming-Hu Chen from National Taiwan Normal University. And the title is